All right, hi everybody. So today I'm going to intro how to use some of the basics with GraphPad Prism. And we're going to go over some of the basic graph types, which are going to include XY grouped, which is what we think of as a bar graph, and then column, which is where we can stack replicates from like group A, group B, group C, and go from there. Um, so we have our faux data here. Hooray. Look at these poor low and high attenders here for class. Still have some of the summary data, but we're going to kind of start over in GraphPad, go over here. So I don't know if I can make this bigger. So GraphPad Prism's great. It is paid, so you won't see this in everyday life, but if you end up at a medical center, science in any way, there's plenty of people that use this pretty frequently, up to the point that having it on your resume as like, I'm proficient in Prism is never a bad thing. So hopefully this helps a little bit. The cool thing too is that with access, you get great little tutorials from Prism, great videos. I would definitely look into these if you want. It can never hurt, right? Because mainly today what I'm going to do is just kind of show you the main sources of confusion, how to overcome them, and just some basics to how to get stuff on here. We might be able to do some stat type stuff, but technically we haven't covered that in our bioinformatics data visualization class yet. But why not? You guys are smart. So guides, another really cool place to start if you ever want is go to graph portfolios. These are all like little example data pieces, super fun. You can make all kinds of cool stuff. And with the data in here, you can actually see how they like sort of got everything. There's ones with very strict tutorials in here. Some of these are a little more, advanced, but at the same time, if you could make all of these, like, you're an expert, that'd be awesome. We will do, we won't do a bunch of these today, but let's just start right here. All right, so let's start with everybody's favorite, X and Y. Hooray, X and Y axis can always be pretty good. So in this case, it's always going to ask you for the Y, do you want to do replicates or do you want to do just a single value so that one point shows up and you're not doing kind of what you see up here with the replicate values? To start, that seems fine. So let's go ahead and take a look in here. And notice you could have also imported your own data and they have like little tutorials for you. That's also fine. All right. Well, let's try something obvious. Let's say that the attendance is the X value. Oh, I'm not going to do attendance because there's too many hundreds. See that? That's going to be ugly on the end. Let's do exam one. Can be our X value. Oops, and that W person is going to cause me some trouble there. Let's see if I can't insert and then shift cells down. Yeah, okay. So I'm going to say exam one. So that's our X. You can only have one X value. Notice that. We're not going to be able to, here, I'll just do the full thing so we can see it. We'll be able to add more Y values, but we only will have one X value in this case. So in this case, let's just see how they did on exam three. Not too bad. Hopefully everybody's doing well. Hooray. I'm going to skip that W person this time. And we should be good there. Okay. And notice like people are going to get zeros or X's if they didn't make it to the exam, et cetera, et cetera. Those points will just be labeled off in that case. All right. So then you're going to go over here to data. So you have data tables up here, graphs, and then it's going to start giving you a preview like this. I would say you can do all these like different formats. As you can tell, we're not really doing connected data, so you would not use any of these like line type crazy things or any of the space filling models. It's a little chaotic. Probably just go with points only. Equally, you have the option to go into a different type of family here, but as you can tell, our data might not actually like quite fit what we're after. See all that? Like we input X and Y data. It's not going to work as just like a strict bar graph. Contingency, it's all crazy, et cetera, et cetera. Parts of a whole won't even do anything. Yeah. Told you guys not to use pie graphs, right? It actually looks pretty trippy and fun, but that's every data column, right? So that's the main thing with Prism. Be careful what type of graph you're using. You can get super kind of messy. But in our case, this looks pretty good, right? We have a nice little setup here. Hooray. Again, usually you can just delete the title here. You can rename this. You can say E1 versus like E3 maybe I'm going to do. That was just a little right click. The axes are here if you want to move them. Here's the other thing with Prism. There's different features on a graph that you have to sort of catch in order to edit that part. So if I want to edit the dots themselves. Click on them. You're going to have these options up here. Up here, here's all our data sets. I'm going to say I want to change all data sets, even though I only have one right now. Show symbols. This is great. You can change the shape. You can do the size different. You can do the border, different color. For example, let's just say let's do this hideous salmon color right here. And if you're in the middle of stuff, you can just say apply without having to like totally hit OK. Yeah, look at those. Those looks nice and chunky. That looks fun. Data sets on graph is going to be here. This is going to be if you have multiple sets. We only have one right now. Graph settings. Let's leave a gap actually do. Yeah, see, it's not going to do anything. So if I wanted to adjust, so see how I have tick marks down here, for example, but not over here. And the fact that remember, 100 is the max. So in this case, see how I'm in a different menu now. I double-clicked the axis. I did not double-click the body of the graph of the dots. Clicking the axis will get me here. So in this case, unclick this, and now you have free reign to decide. For example, I want my maximum to be 100. I want minor ticks every 4 because that looks good. I want to have major ticks every 20 for the percent. So I'm going to apply that. Let's see how that looks. I clearly was able to extend it a little bit. That was nice. All right. Same thing on the y-axis right here. I'm gonna get that on my own. I want this to be the same as my x-axis in this case. Again, I'm working with pretty easy data here, 2 different exams, et cetera, et cetera. So not too bad, right? There's some formatting stuff here you can always mess with, but the standard GraphPad format is, unlike Excel, typically welcomed in the science community. But you're always welcome to like do other stuff with like your format. Like here, if I wanted to make this more of a square, I can just take those 2 values, apply them like that. Now it's going to make the whole thing a square. If I wanted to, you can add like a frame to this thing in this section. It's not too bad. All right, so let's take a look as well. If I'm on the x-axis, one cool thing that you can also do is I can add a line at a certain x value. So I remember, I'm pretty sure on exam 1, the median was something like, I think it was a 71. So I'm going to add that. It's going to automatically do dots like that. You can change the format of that if you want. And I'm pretty sure 68 was the median on exam exam 3. Actually, yeah, wait a sec. On this fake exam, obviously. I think it was like 62. Yeah, so there you go. That's kind of a cool like set of features you can do to like kind of mess with stuff. Hooray. Now, if we wanted to, you can do, if you want to go up here, this is where you would be able to start like doing some stat type stuff. Now, Prism's an excellent graphing software. It's a pretty good stat software too. It's not one of the king stat softwares, but it's a lot easier for the user than Excel for sure. So sometimes, depending on your graph, you'll have these little shortcuts up here. Check and see. You'll probably be using one of these, but you can technically do any type of test on here that it allows. I have some recently used ones, normalized. Here's a bunch of the main ones for XY analysis. You can technically like chunk things through the different analyses, even if it's the wrong data, but it'll usually yell at you and give you an error message. So linear regression, that sounds fun. Let's push through here. You can interpolate everything, test departure. I want to show my, yeah, this is a cool one. Graphing options. Always show the confidence bands. It's kind of neat looking. There you go. And then see what we've added here is a regression line and then confidence bands and the dot. Now, if I wanted to edit that line specifically, see how my mouse has to catch it? In this case, let's say I wanted to make this some horrific green, I don't know, like that. Let's do dark green right there. So see how, in that case, I added kind of that color to things. This is looking pretty gross right now, but hey, I'm trying to get everybody's attention. I'm not gonna spend time on it now, but if I wanted to, I could probably crush this. I could probably start this axis at 20 and this at 20 to kind of shave some off, but there's never anything wrong with having double zeros down there. Always honest, hooray. In terms of if you wanted to do the scale different, you can go into here and you can do like a log 10 scale, for example. So now things will kind of like spread out a little better since we're doing base 10. Okay, that's horrible. Never mind. Let's try log 2. Yeah, I mean, you can kind of mess with stuff like this. It's going to depend on your data and like what you're up to in some cases. I'll be 100% honest. Control Z or Command Z for Mac people. typically just take yourself back to where you started. It's a good program to mess with things and decide what looks good and what doesn't. So that'd be my suggestion for some of these. As far as like if you're in the middle of doing your stuff, here's some other good stuff in here. If you want to choose a different type of graph and you're in the middle, you can go back to this stage right here. You'll start kind of pushing things in here again. It'll start asking about this. Again, though, most of these formats are not going to work for the specific type of data, like a straight XY like we're doing. But it's good to experiment with different kinds of data. And like I showed, those tutorials that are in Prism are great places to start. As far as if I needed, for example, to add some stuff. So not only did this linear regression add a line for me, it added something special. In the results right here, these are the results of any of our stats tests. Let's take a look in here. So typically this is going to give a wealth of like stat stuff. Not all of us are stat people, so you can mostly what you're going to need to do is hunt for the thing that you're after. For example, R squared is a good place to start. How much of the X value is sort of predicting statistically the Y value. Our R squared is this value right here, 0.4582. If you wanted, one of the easiest ways is to just go to this little text bubble, say R squared, and then we have a nice little superscript right there. R squared equals, oh no, now it's done my superscript. It is a little clunky, kind of like Excel when you're editing stuff, but what was it? It was like 4523. There you go. And then you go here. Nice. Looks good. You can add this in here. You can also technically copy paste this value that we saw in here, because again, 4582. If you're running a bunch of repeated analyses too, you can actually set up like an R2 equals with nothing next to it and then copy paste this value from in there. It'll automatically show up. Again, that didn't take me too much time though. So if it's one of those, that's easy. Otherwise, yeah, I mean, you can get some pretty good stuff done. There's some other analyses for XY. I mean, you can do a correlation, like strict correlation analysis, see how it looks. Remember with correlation analyses, they're pretty prone to just getting overwhelmed by the number of pairs that you have and deviating towards significance. That said, this is pretty significantly correlated data. But again, doesn't technically show causation, but that's a whole nother conversation. But it is good to show at least like if you're on the right track. Confidence intervals, everything you might need. So I don't know, I might probably not gonna save this little guy here, but if you wanted to just quickly save stuff, you can always copy graph. You can always like obviously save like normal stuff up here, copy graph, and then if you take it into PowerPoint and just have like a sheet of like, here's all the figures I've been making, you can just save it as a photo. That's going to be a right click and then click on the little photo icon. That can be really helpful. All right, so I'm going to do a new one this time. Let's go to grouped. This is going to be, oh, wait, actually, sorry. One last thing with XY. So we did exam 3, right? This is still our X for exam 1. Let's do a different group and measure it. So in this case, let's see everybody's lab percent based on their first exam. There we go. And this one's actually going to fill in because I did interpolate everybody's lab. All right. There we go. So now the legend's going to start showing up too. And I actually didn't name this. So I'm going to say like lab percent. Sorry, you guys thought you were getting away from XY and moving on. All right. So now in this case, we have a new thing. We can go in here and do the edits like we were just doing, right? I'm going to make this looking pretty big. I'm going to get the border all nice. Looking good. What color should we make it? How's that look? Yeah, it's kind of gross. The regression analysis is also going to repeat and add our line right here. But typically, this is actually a pretty good way to like kind of see and visualize stuff. Again, this data is getting pretty crowded. And actually, in a perfect world, what you can do here, if I wanted to reduce the size of everything, instead of going back and forth between each group, what you can do is just say change all data sets and say, all right, I want this size to go down to a 3. Let's try that. Now everybody went down to a 3, for example. Much better. Hey, it's not a bad looking little thing. Well, okay, it's pretty bad looking because I added the green and everything. But hey, I was just trying to mix it up, you know. You can always find a place for your legend if you can reduce the text size. That corner actually seems pretty good right there. Sweet. So that's how to do multiple little populations in an XY. Looks really colorful. This is also how you can like detect covariations, et cetera, et cetera. But for our next magic trick, Let's go to something a little more basic, grouped. In this case, again, we're just going to do a single Y plot for each point. Nothing crazy. So for example, if I just wanted to say, I just want attendance percent, what I'm going to do is just make a nice little bar graph of everybody. So this is actually going to be pretty dense. Hopefully it doesn't look horrible. I'm going to take all these values, and technically what you can do is take the random identifier over here on the left right there. You can take them if you wanted and say, I'm going to add this as my title for each subject, even though, again, it's a random ID. It's nothing. But let's go to data. And notice that I arranged it in Excel. If I hadn't, there's not really a good way to arrange things here. So make sure that you organize things in Excel before you put them in. All right, looking hideous. These are just if everything was just a single point. Again, this is actually technically probably what I'm going to want over here, summary data. These are just going to be bar graphs. Notice that it's like trying to do like different population bar graphs, but in our case, we just have one right now. So you can just go with this to start. There's some other goofy stuff, like it'll technically do each bar as a heat map if you want. 3 ways odd. Let's not do box and whisker. But yeah, summary data is your easiest one. Let's go in here. There's a lot in here. I should have maybe reduced the population. Let's look into here. So first thing you can do if the things look a little dense, notice that the border is like 1/4 and it's like kind of on top of itself. Border color, let's actually reduce these to some gray. That's still a lot, so it's like not even showing up because we're just seeing the border in this case. Oh, there we go. See, there you go. So perfect. Now you see we can start to see some separation here. That actually looks pretty good. It's 162, so it's a lot. All right. X, we don't really have a title there, right? This is just students, right? Like hours worked. So you probably can just leave that blank. Oh, no, I just clicked something. You can probably just leave that blank on there. Delete. And to get rid of these ID numbers, if you don't want to label them, if you did want to label them, you would say, I want the major ticks to be the row titles, and I want to apply. Look how dense that gets, though. Probably what I'm going to do is just say, get rid of all those titles down there. Nice. If we just want to visualize attendance percent. Okay. Again, I can probably go in here. I'm going to make this perfect. And actually, no, I'm all meticulous now. I'm going all crazy. I want my little ticks. Done. Okay. Now we're all set. Don't need a title either. All right. Nice. Looks pretty good, right? Now, if I wanted to add some sort of like flair-ish to this, you can always, what you can do is you can say, notice how I've got it arranged. If I wanted, I could say 90% and above. You can take an X, command, sorry. So highlight everything, same rules as Excel, the shift and the control clicks, move it over. Now that I'm in group B, what it's going to do, at least in this format, going to make it a different like sort of color format. So I'm going to change all data sets. I'm going to make sure the border is nice and small. I'm going to go back to this nice gray. We're sort of back here. Oh, what are we doing? Change all data sets. And then if I want to say data set B and I want to say, hey, look, these all did so well, actually give me a bit of a hard time right now. Appearance bar. Dang it. Yeah, it certainly didn't like that very much. Yeah, so hence sometimes things get a little unfortunately wonky with how the bar graphs decide to be put up if they want to. My intention was to take everybody that's above 90% and then color those bars green. I might come back to that. This always happens to me though. Okay, let me take one last look before I. Yeah, it's clearly not having it super well here. So why don't I try a different type of graph here? Definitely don't want to interleave anything. Okay, is that gonna, okay. Kind of had to change the type of graph, I think. Yeah, it's not super happy. Sad. Okay. Well, we'll figure that out. Don't worry. I'll get back in one of my old data sets that has that. Anyways, you can do some pretty decent bar graphs in here. Hooray. Not too bad. And if I wanted now, for example, to do attendance plotted with something else as the second bar graph, that actually probably wouldn't be too bad. You could say, let's go to class, for example, and go here. I'm going to copy this in. Oops. Again, we grabbed that W right there. Go. Done. Okay. Done. Okay. Class percent. This might be kind of a hideous bar graph because they're sort of aligned against each other, and there's a lot of them. I think what I should have done a while back was just say, all right, let's look at the low attenders, everybody below 60%, and nobody else. This will sort of get things a little nicer. Finally, see, I knew they were in there. All right. So now what we can take a look at, and I'm going to get rid of student 529 because they never showed. Okay. Now what we have is a nice little double bar graph, all good looking, hooray. What you can do in this case too is you double click these. Now you can start to say, okay, I want to mess with this. Do I want attendance first or do I want class data first shown? So I just switched that like that. Now I apply. Now you see you can like kind of have that all set up. Notice right now that they are still arranged based on in gray in the attendance. Graph settings too. Another thing you can do here is sort of make your bars a little bigger in this case. We don't have any missing cells between adjacent data. Maybe I'm only giving them 10% of space. I don't think we have any additional gap between groups. See how it goes. Yeah, doesn't look too bad, right? In fact, I would, though, probably want to get some more space between groups. So maybe I will give that actually a 50. There we go. Now that's going to see like nice little pairs. You could add a third set of data on the edge too if you wanted. In fact, let's just go add some lab amounts right here. So I'm pretty sure we had, what do we have until 60? So it's going to be this person. Nice. And there we go. Lab percent. Nice. Now, anytime you add a new group of data, it's going to come in the standard, like kind of gross looking format. So just give it a little go like that, and you should be okay. You can kind of zoom in, make sure everything's looking okay. Cool. So if this is what you wanted to arrange, definitely not bad. In an emergency, what you can do right here, if I wanted to arrange it, so see how it's arranged from attendance low to high. If I wanted to change that, a very quick fix is going to be, can I just reverse the row order? Done. Go back. Now it's going from high to low attendance in this case. In this case, and if you want to fix something like that, you can always do that. You can manipulate where these are going. It has some good like fitting and alignment tools as well. So not too bad. The analyses you can do on grouped are going to be ANOVAs, which is analysis variance. In some cases, this isn't going to be preferred with the data we've got either because we don't have any replicates in there. We're going to kind of wait on that. So another thing that I wanted to show you was, and this is going to transition us to our third and final data set for the day. So down here, I still have basically my high and low attendance groups. And if I want to just make a summary bar graph like this, how's this going to happen? There we go. That's not bad, right? Those are just input from the averages I did in Excel. But I don't have any variation. Each of these groups is like, 80 each. It's not showing that. This is where we turn to probably the most useful graph in Prism, which is going to be a column. Let's go over here. A column is going to do, we're going to get replicate values, stack them into each group A, group B, group C, and we're going to see what happens. So I'm going to create one of these. So the bar graph can do a nice summary of something that we've already done, but technically column's going to do that for us, but it's also going to add all the stats, all the variation, everything we need. So in my case, what I want to do is I want to say low attendance, how'd you do on exam one. So I'm going to get all these low attendance people on exam one. And I'm going to go in here and I'm going to say low E1. This is my low attendance E1 exam one group. I'm going to get everybody else, grab them. And the cool thing here, you're not aligning anything in this case. You're just saying, here's my group A, here's my group B. Done. There we go. So now in a column, you're going to have a lot more choices of how you graph this data. In this case, right now, what I've got loaded is just individual plot points set up. That's your most honest. It shows all your data. It's not pretty sometimes, especially with a lot of data. We can kind of run around and fix it. Let's take a look right here too. You can add the little plot lines that are in there. You can kind of see them like poking around in there. You could just do, for example, the average. See how they're going to move down there? You could do the average with the standard deviation. For the most part, well, this data isn't super normal though, right? Normal data is the best for for averages and such. And that histogram should be pretty like edges and mountain in the middle. It's not really like that. So a good idea sometimes is just do median with confident 95% confidence interval. Not too bad. So we got individual values. You can add a bar with the values. Notice this one you would not use because I'm not saying that the group A and group B in the same row, the data, they're not paired. But if they were, if it was like a before and after, that's how you could use this one. And you can turn it on its side. Totally format, totally like whatever you want to do. All right, box and violin, a couple of these other plots. Here's box and whisker plots, for example, and you can decide what you want to use. You can include some percentile and show like the high ones. You can do just a straight violin plot. Violin plots can be really pretty. They can be kind of clunky sometimes. See, they're like a little like they show the histogram. It's pretty nice. Median plots in this case, again, lots of how you want to do things. If you did just want to do the bar graph right here, that's fine. Technically, you can get an average with standard deviation. You can do the median instead. You can do little plot points like that. Looks pretty neat. You can connect them if you wanted, but in our case, again, this isn't really connected data, and then on the side. So y'all know me. I absolutely love individual data plots. Let's go here. Okay. Look at all this, looking good. They are a little squished, I admit. So let's actually take these, get them a little smaller, and let's get that border small. Right now, they're actually transparent. Is that shading right now? That doesn't look too bad. Yeah, I don't mind that. I'm going to definitely adjust right here though and say I want max is 100. Let's say 20 is the minimum in this case. And let's do some major ticks at 20. Hooray, hooray. All right, how are we looking? That's not too bad. You can kind of spread things out too. Hooray. So now if I wanted, now I could say, all right, like for the high attenders, for example, I could color them this sort of weird money green right there. And for the low attenders, I'm going to color them as bad salmon right there, right? Shoot. Now for the error bars themselves, you can also change in here. Now I've kind of spent my color palette already, so we can do something hideous like blue. Well, blue's not hideous, it's just going to be gross. Now I can apply there, see how that error plot, you can change that, how that looks. Like I said, you can change the thickness, et cetera, et cetera. To make it more pronounced, you can say to go underneath, you can tell it to go on top of your data. Most of the time, you're going to want to just sort of leave that pretty standard. You can color the data points in a lot of cases, but et cetera, et cetera. I'm going to leave it as a hideous testament to what is possible. So I'm going to say percent, exam percent, basically. And I have a caption. All right, so in the last closing moments, what column can do the best for you is stats tests that Excel and some of the other stuff is not going to have a very nice way to do. So we have group A, we have group B. In the analysis section right here, we're going to have a bunch of options. Mostly right here, you want to do compare two groups, you're going to go here. A t-test is how you compare a group A with replicates and a group B with replicates. I've been advised thousands of times, use the Welch's correction. It's going to assume that both groups do not have the same standard deviation, which is likely not going to happen with your data. So run it. Well, there's some options in here. This is more stats. leave it at two-tailed because you're not saying direction in this case. You're not assuming that one is going to be bigger or higher than the other. I can add some descriptive stats and let's run. All right, so this is going to take me to the results stage. There's my p-value, Welch's correction, super high, hooray. It's going to tell me degrees of freedom, the t-value itself, the mean of the columns, the plus and minuses, variances, descriptive stats of each column is great to have, minimum, medians, percentiles, everything like that that you would want. Now, that's the trick. I showed you in Excel how to do a lot of these stats and stuff on these populations. If you just do new analysis and do descriptive statistics on both, it's going to spit out everything that you would have wanted. Quartiles, kurtosis, skewness, all this weird stuff, like anything you want. And it's going to be a lot easier than plugging a lot of those formulas in. So if you're going in here, now one of the cool things that that Prism can do, add comparisons. This is actually going to assume, since we only have one test going, it's going to add the significance. If we had multiple tests going, it would ask like, hey, which test do you want to show? But in this case, looks pretty good, right? And that's going to add these little guys. If you want to manually add these, you can always, you would have to go in here and do one of these little things. And then you could say like, all right, it was significant, things like that. But if you can automatically add it, it's pretty easy. So given that, I'm trying to think of some other formatting and some other fun stuff. If what I really want to do is actually add a third group, but I kind of used everybody just now. What I could do, let's do one last little thing. In this case, let's do the same analysis, but I'm going to say, let's say, I'm going to say group 1, group 2, group 3, and group 4. Sorry, I'm just slapping this together super quick. Let's go in here just to make 4 groups so we can do one last little test. I'm just going to split. I'm going to do everybody's exam 1. I'm going to split the lows down the middle for attendance. So let's say like attendance at 75 or less is group 1. Yeah, so I'm just trying to make 4 groups here pretty quick here. And then I'm going to say attendance at least 88 or at least below 90. It's group 2. Let's call this at 90. Yeah, like that cutoff, that 95 right there is group 3, where they like maybe only missed 1 or 2 classes. And then the last one is going to be my elites who never or only missed 1 class potentially. Okay, so now we did 2 groups. That allows you to do a t-test, but plenty of times there's going to be more than that. And notice now I got 4 groups. My t-test just went blank because it's like, hey, that's too many groups. You can't do that. Okay, so now if I wanted to go in here, notice how I've got these new groups right here. I can see, even just eye test, I can see that so long as you cross this threshold, you're looking pretty good. Now I can do 3 or more groups. Let's click that. All right. We're not going to do matching and pairing. We're just taking the like means of each group. If you did do the row, it would mean that each row was somehow connected, like at like a state, like a timeline. Don't do that unless that's the data you have. Okay, you can use the little ANOVA, the Welch ANOVA test as well. In our case, let's just do it regular. All right, so multiple comparisons. So what an ANOVA p-value will give you is just say one of these groups is different. Somebody's different. To get a really good comparisons between each group, compare the column to every other column. We're going to do multiple tests. And this is going to allow us, you can do Tukey, home SIDAC is fine too. These are all multiple comparison tests. So remember, if I had done 100 t-tests, 5 of them would have randomly been significant, right? Because 0.05 p-value. Multiple comparisons is going to stop that for us. So I'm going to run this. Our total p-value for an ANOVA it shows significance. Somebody is different, but let's look in here. Multiple comparisons. This is going to say which groups are significantly different after it's all said and done. A couple of these were close, but did not meet the test. So let's go in here now. What we're going to ask it is say, okay, based on these groups, give me everything that you can from this ordinary ANOVA right here. The NS is not significant. You can always delete these and it is assumed that is not significant. So as you can tell, it's mainly still that really low group that is going to suffer on the exams, in exam 1 in this case. All right, so ends our video for now. Hopefully this is a good intro. I'll do some more Prism stuff as we get going into some of the more advanced models, but hopefully this is a good little start. The best way to practice this is to dive in or use the tutorials and then dive in with some of their data. But again, we'll have our own as well. Thanks again for watching.